The Earth consists of the lithosphere, hydrosphere, and atmosphere. The lithosphere layer is a layer in the form of a soil membrane comprising a variety of rocks. The hydrosphere is a layer of water that covers and even permeates the lithosphere layer, and the atmospheric layer is a layer that covers the entire lithosphere and hydrosphere. The Earth's surface is made up of 1/3 land and 2/3 ocean, with an area that covers 2/3 of the Earth's area. It is necessary to make efforts to explore and utilize the natural resource contained in it. Earth global change often is a phenomenon in which the ocean and its interaction with the atmosphere and biosphere play an important role in Earth's changing system. Knowledge of the global aspects of ocean circulation is lacking. This is due to the challenge of collecting or observing ocean data, where the fluctuations that often occur are fast and large, both spatially and temporally. It is necessary to develop science related to the ocean, such as geophysics, oceanography, meteorology, geodesy, geology, and other scientific studies.
Satellite systems are one solution to the problem of obtaining the data needed to study global ocean phenomena. Several satellites were launched which are made for the purpose of studying the dynamic of the ocean, namely altimetry satellites. Altimetry satellites began to develop in 1973 when the first altimetry satellite was launched, the Skylab satellites by NASA. Altimetry satellites principally aim to understand more deeply the global climate system and the role played by the ocean in it, which is then described as follows. 1. Global ocean circulation monitoring. 2. Measurement of the volume of the polar ocean. 3. Observing change in the global average sea level. Since the launch of Skylab in 1973, to the data, several altimetry satellites have been launched with a specific mission, with its ability to continuously observe the topography and dynamics of the sea surface. Altimetry satellites are not only useful for monitoring change in mean sea level globally, but will also be useful for several other geodetic and oceanographic applications.
The basic concept of altimetry is measuring the distance of R from the satellite to sea level. Altimetry satellites send strong short-wave signals to the ocean surface, back to the satellite. The signal hits the sea surface, which is then reflected back to the signal receiver on the altimetry satellite. Altimetry satellites are also equipped with very precise timekeepers. The principle of measuring sea level from altimetry satellites is the height of the object surface from the reference plane, which is from SA, or altitude of the satellite from the reference plane, is deducted by the measurement distance between the object surface and the satellite, RJ.
Satellite altimetry. Satellite altimetry technology is a remote sensing technology The is used to observe the dynamics of the sea surf topography. The is reference to a curtain field. The specific plane can be a hex reference plane, which can be a ellipsoid, geoloid, or main sea surf. The his time is general. The satellite system has three long-term objectives, namely, number 1, observing global ocean circulation. Number 2, monitoring the volume of the polar ice sheet. And number 3, observing global mean sea level (MSL) change.
As given a bidding 2001, satellite altimetry is not only useful for monitoring global MSL change, but will also be useful for several geodetic and oceanography applications as given: determination of sea surface topography (SST), determination of the air surface topography, determination of the gauge in the ocean area, determination of current characteristics, determination of the high significant and lake dominant of the wave tidal study of the coast, determination of wind speed above sea level, determination of the boundaries of the sea and ice, investigating the El Niño phenomena, and marine resource management, verification of high data between islands.
Altimetry satellite application in geodesy and other related fields include determining seashore topography or SST, determining ice sheet topography, determining characteristic and pattern of current, tide, and wave, determining wind speed above sea level, determining geoid in ocean area, determination of sea boundaries with ice sheet, and unification of high datum in archipelagic area. What is meant by SST or sea surface topography is the deviation of the sea surface from the geoid surface, namely the difference in ellipsoid height between sea level and the geoid surface. SST itself can be divided into two components, namely static and dynamic component. The static component is mainly caused by ocean currents, meteorological effect, and inhomogeneities in the distribution of salinity and seawater temperature, while the dynamic component is mainly caused the phenomenon of waves, tides, and variation in air pressure.
Altimetry satellite can also be used to study SST variation with time on regional spatial scales. Study variation of MSL or mean sea level with time, determine spatial variation of gravity anomaly, estimate ocean current speed and patterns, and estimate wave height, significant as well as wind speed. In addition, altimetry satellite can also be used in various fields. For example, in the shipping sector by determining and optimizing shipping routes, in the military field at sea by determining the weather or condition at sea, especially for submarine routes, and in the fishing industry by predicting the pattern of fish distribution in the sea.
Advantages of using satellite altimetry include high spatial resolution, consistent accuracy, continuity of time, independent surface engineering alternative, evaluation in relation to a geocentric frame of reference required for sea level, ocean circulation, and tides. However, there are some significant drawbacks to the use of exclusive altimetric data, namely, coverage is limited in time. Only about 20 years of data is currently available from all missions combined. Poor performance along the coast, limited and uncertain observation on land necessitates a connection between land surface and sea level at the boundary. And the last one is polar
The
coverage.
conclusion
For
of this
instance,
topic
what is
are
actually
the
being
satellite
recorded.
system is one
Example,
solution to the problem
signals
of
on
obtaining
deep
the
snow,
data needed to study
ice,
global
and
ocean
glaciers.
phenomena. Satellite altimetry technology is one of the remote sensing technologies used to observe the dynamic of the sea surface topography that is referenced to a certain field in the form of a high reference plane, which can be an ellipsoid, geoid, or mean sea surface. In principle, it has the goal of observing global ocean circulation, monitoring the volume of polar ice sheets, and observing changes in global average sea level. The basic concept of satellite altimetry, which is measuring the distance r from the satellite to sea level. The altimetry satellite sends a strong short-wave signal to the sea surface, which is then reflected back to the signal transfer on the altimetry satellite. Altimetry satellites are also equipped with very precise timekeeper. The principle of measuring sea level from altimetry satellite is SSH equals SA R. Altimetry satellite can also be used in various fields such as shipping, the military field, at sea, especially for submarine lines and in the fishing industry. Thank you.